prohibition of bus duct plug-ins above drop ceilings in environmental air applications primarily stems from concerns related to fire safety. The plastic insulators used in these plug-ins pose a significant risk. Plastic insulators generally have a lower melting point compared to the metal housing of the bus duct. In the event of a fire, the plastic insulator can melt, releasing toxic fumes into the environment. These fumes can accumulate in the plenum space above the drop ceiling, creating a hazardous atmosphere for occupants and emergency responders. The presence of these fumes can also hinder fire suppression efforts, as they may obscure visibility and complicate the identification of the fire source. Another reason to not use bus duct plug-ins above drop ceilings is their tendency to disrupt airflow in the plenum space. Airflow is crucial for removing heat generated by electrical equipment and maintaining a safe and stable temperature. When plug-ins obstruct the airflow, it can lead to localized overheating, potentially increasing the risk of fire or equipment malfunction. Adequate airflow is also necessary to prevent the buildup of dust and other contaminants, which can further compromise the performance and safety of the electrical system. Accessibility for maintenance is another factor influencing the restriction of bus duct plug-ins above drop ceilings. Placing these plug-ins in the plenum space makes it difficult to access them for routine inspections, maintenance, and repairs. Proper maintenance is essential to ensure the continued safe and reliable operation of the bus duct system. Without easy access, it becomes more challenging to identify and address potential issues such as loose connections, damaged insulation, or corrosion. Poor maintenance can increase the risk of electrical faults, fires, and other hazards. Most building codes specify that bus duct plug-ins must be installed at least 6 feet above the floor in general-purpose applications. This requirement ensures that the plug-ins are readily accessible for maintenance and reduces the risk of accidental contact. In environmental air applications, this requirement is typically extended to the plenum space above drop ceilings, further restricting the placement of plug-ins. The plastic insulator material used in bus duct plug-ins can degrade over time, particularly when exposed to high temperatures or chemicals. This degradation can weaken the insulator, reducing its ability to provide adequate electrical insulation and increasing the risk of electrical faults. Dust and debris that accumulate in the plenum space can further compromise the integrity of the insulator, accelerating its degradation and increasing the likelihood of failure. Plug-ins can introduce additional voltage drop and power losses into the electrical system. This voltage drop can affect the performance of connected equipment, leading to reduced efficiency and potential malfunction. Power losses can also increase energy consumption and operating costs. By minimizing the number of plug-ins and optimizing their placement, it is possible to reduce voltage drop and power losses, improving the overall efficiency of the electrical system. Therefore, to ensure fire safety, maintain proper airflow, and facilitate maintenance, bus duct plug-ins are generally not allowed above drop ceilings in environmental air applications. These restrictions are in place to protect occupants, equipment, and the building itself from potential hazards. The primary concern is fire safety, given that plastic insulators used in bus duct plug-ins have a lower melting point than the metal bus duct housing. During a fire, these plastic insulators can melt, releasing toxic fumes that can accumulate above the drop ceiling, thereby creating a dangerous environment. Airflow disruption can also happen in the plenum space. Plug-ins can impede airflow, which is essential for removing heat and maintaining a safe temperature for both personnel and equipment. This obstruction can lead to overheating and potential fire hazards. Accessibility for maintenance is also key to consider. Plug-ins situated above drop ceilings are difficult to access, making routine inspections and cleaning more challenging. This poor maintenance can increase the risk of electrical faults and fires. Also to consider, most building codes stipulate that bus duct plug-ins be installed at least 6 feet above the floor for general-purpose applications. This height requirement is often extended to the plenum space above drop ceilings in environmental air applications. Additional considerations should be made because the plastic insulator can degrade over time, especially when exposed to high temperatures or chemicals. Dust and debris in the plenum space can further compromise the integrity of the insulator. Plugins can introduce additional voltage drop and power losses into the system. In summary, bus duct plugins are not allowed above drop ceilings in environmental air applications to ensure fire safety, maintain proper airflow, and facilitate maintenance. These restrictions help protect occupants, equipment, and the building itself from potential hazards.